Today we're going to begin learning about forces, accelerations, and car accidents. We're going to be learning and applying Newton's laws, impulse, momentum, and pressure, and how they all play a large role in car accidents. By understanding what causes the damage, or large forces, we can also use a knowledge of physics to help save lives. So as many and most of you are learning how to drive, it's important that we pay attention to what's taking place of the physics behind driving cars and car crashes. Here goes. Notice that in this test crash of an older car, the car has a very rigid frame. The rigid frame is right here. So it comes to rest almost immediately while the body of the car keeps going at its current velocity. The body itself has no crumple zone, so it comes to rest as it hits the wall. And the people are then brought to rest immediately. Let me replay this video. They're brought to rest immediately as they strike a very solid items within the car. Remember, it takes the same impulse. It's impulse right here, which is we're going to learn about the change in momentum to stop the people in the car. This car uses a small time, so the force must be huge and quite deadly. This is just an illustration of an older type of car. Obviously, the frames and the dynamics of the car, the mechanical parts have changed significantly, but this would actually lead to let's just say a traumatic, painful, and likely death of a car accident. So this was the video number 1. You should be able to follow the handout and answer the questions for part 1. Crash tests without seatbelts. Cars are designed with crumple zones so that they may slow down over a longer period of time, or a larger period of time, which keeps the force smaller. However, this safety feature alone will usually not prevent serious injury or death to the occupants of the car during an accident. Here we see the crumple zone right here. This is increasing the time of the collision. The crumple zone only slows the car more gradually. The only way it slows the occupants more gradually is if they are attached to the car. Otherwise, the car may come to rest more slowly, but the people come to rest immediately upon striking the already stopped interior of the car. Stopping in a small amount of time means that the force must be very large. This video clip shows some very dramatic scenes of car crash tests with test dummies who are not wearing seatbelts. Specifically, look for cars crumpling and people stopping in very small amounts of time. Here's our crumple zone. We'll talk a little bit more about this. Here's the crumple zone. As it begins to collide with the wall, the car doesn't come to rest instantly like it did on the first video. Instead, the crumple zone allows for the car to come to rest over a greater period of time, therefore decreasing the force acting upon them. So essentially we're changing an individual's momentum by increasing the time of the collision. Okay, that was video number 2, crash tests without seatbelts. Go ahead and answer the questions. All right, this video is going to involve children become bullets in an accident. Here goes. This clip illustrates what happens to children in a car accident if they or their car seat are not properly belted in. This particular car seat was flawed. Remember, if the car was going 55 miles per hour, then any person or object in the car is also going that fast and will continue to go that fast until a net force acts on them to slow them down. I think it's important to make sure we pinpoint or identify here that the rotating dial makes one rotation in 1/10 of a second. So this was used to measure small intervals of time on like pre-digital clock film. But this whole time of that collision was 1 second if you count up the number of rotations of the clock dial. So in 1 second, bad things can happen. Okay, go ahead and answer the questions on children become bullets in an accident. So this video clip is called Passenger Kills Driver and Self. This is kind of the backseat passenger who's not buckled in. So here goes. This clip clearly gives the driver a good reason to make sure occupants in the car, or in this case occupants in the rear of the car, are wearing seat belts or safety belts. Not wearing a seatbelt can not only put your own life in danger, but anybody else who happens to be riding with you. The force from the seatbelt safely decelerates the driver, but the child in the back seat follows Newton's law of inertia, or Newton's first law, and continues moving in the absence of a net force. The 60-mile-per-hour kid not only breaks his own neck, but the driver's neck also. Remember, just because the front passenger seat has their seatbelt on doesn't mean everybody's safe. Passenger kills driver and self. Go ahead and answer your questions here. All right, this video is called Parent Kills Child with Ignorance. We're simply going to be watching the crash test dummies of what happens here. Here goes. In this clip, we see a parent holding a child, and neither of them wearing a seatbelt. As you can see, the parent not only allows harm to the child, but actually hurts the child more as the child becomes an ineffective airbag for the parent. Go ahead and answer the questions involving parent kills child with ignorance. This video here is called Hit From Behind, and here goes. In this clip, we see that seatbelts and child seats not only protect you in a frontal impact, but they can also prevent a tragedy in a rear end collision. In this clip, the station wagon literally gets accelerated out from under the kid sitting in the back. They were at rest originally, and in the absence of a net force, right, from the seatbelt, they remained at rest while the car they were in was accelerated by the net force from the car that hit them. In other words, the kids were in the back, they stay in one location, right, as the car is accelerated out from under them. They have inertia, they resist change, so they fly through this window as a result of the force coming from the car behind them. So the station wagon they're in is actually literally accelerated out from underneath them. Go ahead and answer the questions for Hit From Behind. This one here is called Bad Guardrails, and here goes. Guardrails are intended to protect people by preventing cars from leaving the sides of the road near cliffs, rivers, curves, and bridges. Most of the time they do this well. Unfortunately, some older guardrails actually pose a threat to lives. If the guardrail does not end by being curved into the ground or in a breakaway design, the rail may be capable of impaling a moving car and its occupants. The ends of these older rails are usually sharp and difficult to see from the end. A rapidly moving car, upon running into one, is met with a very large force and a high pressure, as that force is exerted on a very small edge of the rail. The effect is known as guardrail spearing. So it literally acts as like a knife by the sharp edge as the car travels into this, and this is our guardrail spearing here. It's literally almost slicing this car in half. You may answer the questions on bad guardrails. Okay, the last video we'll be observing is called Crash Tests with Seatbelts. Seatbelts use two main ideas to protect passengers during a car accident. First, they slow the passenger down more slowly than the passenger running into a steering wheel or dashboard. This keeps the force required to stop them smaller. But it also prevents the person from contacting any of the glass windows in the car or continuing on to be stopped abruptly by a road or the tree or another automobile. The video clip above shows, or this video clip you're watching, shows the role of the seatbelt during an accident. So to end this assignment, make sure if you have any questions on answering any of these, of the videos, make sure you go back and watch them. You can go ahead and move on and see the safety ratings of the very automobiles that you find yourself driving in. Enjoy.